All right, so I want to kind of walk you back through this problem one more time so that we can make sure that we've got it down. So um, coming back up here to the original problem, I'll draw it out one more time because this becomes part of the most important part right here is if you can draw it out or not and think through where it's at. So north, south, west, east. So airplane is flying 350 kilometers in the 30 degrees northwest. Northwest is going to be over here in quadrant 2. So since I'm over there 30 degrees from the horizontal, it's going to be about right there. So this is my 30 degrees, and I'm going to call this 350 kilometers. All right, so when I drew out my airplane vectors for this, it's going to be A and B. That's where you can redraw it if you want. I redrew it right here. I did 350 A and my B here. So I knew because A is going over here, it's going negative, B has to be positive. So I made sure that A here was negative and B here was positive. All right, so now the second portion, you've got the wind impacting this. So right here at the end of the arrow there, the resultant there at 350 there, to draw this out, the wind is blowing at 60 kilometers in a direction of 70 degrees southwest. So I'm going to kind of think about this again. Put in north, south, west, east. And it says this time that it's in a direction 70 degrees southwest. So southwest is down here in this third quadrant over here. And 70 degrees looks like it's about like right there. And this is my 70 degrees down here. So kind of to draw out the triangle for this, starting. So starting here, I'm going to draw it over. This is the resultant. So this is my A, this is my B, this is my 70 degrees in there. And it says 60 kilometers per hour. So kind of taking this green portion I drew out there and putting it here. So again, you can tell A here is going to have to be negative, and B here is going to have to be negative. And that's exactly what happened for the wind down here. A here was negative, and B here was negative. So the big thing on here is to know, to be able to draw them out so you can figure out the signs. So because I'm moving to the left and then moving down here to get my resultant vector down here, I have to have a negative and negative. And then the rest is pretty easy. Once you get those values, then you simply add together your two vectors there. So I can take vector airplanes vectors, the airplanes components, and we've got the winds components there. So notice I wrote those out right here and right here. Add together your A values, add together your B values. And then once I get those, then I've got to go ahead now and figure out the magnitude of that, because the wind and the airplane are impacting each other there. So wind's impacting the airplane. So now I got to take negative 323.6 and square it, plus 118.67 and square that, just simply because those are your your new A and B. So you got to basically you're trying to find your C value now. So A squared plus B squared, and take the square root of that will give you your C value. So we got that, 344.6 kilometers per hour. And then the next step there is to go ahead now and figure out the angle, because now this creates a different angle because the wind impacted it. So these two will always end up, your A and your B here will always end up being your opposite and your adjacent there. So you can see that your B value here, if I want to set this up, it's always, if I want to give you a formula, it's going to be like this, inverse tangent of B over A. And so our B value here is 118.67, and our A value is 323.6. But when I do these, because I'm always trying to find the positive angle, I always use B and A, use positive B and A values. So putting the positive values in there. And we end up getting 21.1 degrees northwest. And I figured out it was northwest because, again, I looked at my order, my components there. If I've got a negative and then I've got a positive here, I'm in the northwest quadrant there. So I'm in quadrant 2. All right, so on to our next slide here. This part here has to do with a boat. And for one like this, it's pretty simple as long as you can count and draw out a nice coordinate system. So again, I'm going to draw this out again. North, south, west, east. So some people even use graph paper or whatever you want to use for this. Easy to count. If you like to pull up a sheet of graph paper when you're doing one like that, that works. All right. So it says a buoy start or boat starts at a buoy. So let's say that's right there. Usually start at 0, 0, just easy to do there. You figure out your map there. So it says it travels 3 miles north. So we travel 3 miles north. We're going to go 1, 2, 3. That's 3. And then 6 miles west. Well, west is to the left. So now I'm going to go 6 miles west. 1, 2, 3, 4, 5, 6. So that's 6, right? 1, 2, 3, 4, 5, 6. That's 6. And then it says 7 miles south. So now travel. So this portion in here is 3, and now I gotta go 4 more. So that's 1, 2, 3, 4. So it's a total of 7 because there's 3 here and there's 4 here. And then my next portion there is to go 5 miles to the east. Well, 5 miles. 1, 2, 3, 4, 5. So 5 miles east. Looks like it'll put me right there. So now, what is the bearing from the buoy to the boat? So this is where the boat is. The boat's right there, that green one. The buoy is at the very original spot. That's the blue one. And green equals where the boat's at right now. All right, so we need to go ahead and figure out how far it is. So how far is the boat from the buoy here? Or the buoy from the boat, doesn't matter. And then we also have to figure out the bearing. So we're going to need to find the components here. So our components are right there. Here's our A, and here's our B. So notice we're going to have a negative and a negative for our A and our B. So vector U, we can just find it. How much are we going to the left there? We're going -1. How much are we going down? Oh yeah, 4. So -1, -4. And now we got to find the length. The length there, we're just going to go ahead since we got 1 here for A and we're down here for B here, we've got 4. We can just use our nice Pythagorean theorem. So I can go -1 squared plus -4 squared and then take the square root of that. So what is that? It's 1 plus 16 gives us square root of 17. And if we want, we could approximate that. It's about 4.1 miles. Does not look like miles. Square root of 17, about 4.1. I would just do mi for miles. So now I'm just going to kind of draw out this picture here. We've got so much over, so much down. We're supposed to figure out what that angle there is. Well, if this is -1 and this is -4, again, this is our adjacent to the angle, and this is clearly -4. There's our opposite. So we can use our tangent. So we can figure that out. Theta is equal to the inverse tangent. I told you could just do your B over your A if you want. Because your B will be your opposite and your A there will be your adjacent. Or you can think of an inverse tangent of your opposite over your adjacent. However you want to do that. So in this case, that would be R4 over R1. Remember, we're using the positive values all the time. And if you plug that in, you get 76 degrees. So, and again, we want direction. So we're over here in the third quadrant, and third quadrant there is southwest. So we're going to say southwest. If you want, you could say third quadrant. But we want to know this, and we want to know this. How far? 4.1 miles. And the direction is, or what's the bearing? The bearing is 76 degrees southwest. So again, drawing out the picture. And some people, it helps them to use this on graph paper. So if you want to pull out some graph sheets from and put them in Notability for yourself when you're doing this assignment, that might be helpful for you. Or just bring one out that you can do on your iPad while you're working on this. So your homework is to go ahead now and work on numbers 1 through 9, if you could do those, 1 through 9. So take your time with those, do a good job, help each other out, refer back to the notes. And again, student notes are on there as well, so you can look those up as well. All right, have at it.